Hello everyone, my name is Deepika and today in this video we are going to perform unsupervised machine learning. So the problem statement is that from the given iris dataset we need to predict the optimum number of clusters and represent it visually. Now I would like to give a brief introduction about the iris dataset in which we are going to work. So basically, iris dataset is the flower dataset consists of three species of flowers. Dataset have four characteristics column, namely sepal length, sepal width, petal length, and petal width. And based on these character, we predict which species it belongs to. So let's get started. Now, first of all, we will set the working directory. Then we will import the libraries which are required. Now to understand the data, first of all we will import the dataset and now we will look into the data. So as I earlier mentioned, dataset consists of four characteristics of flowers and a species column. So the shape of the dataset is 150 rows and 6 columns. Now we will look into the basic information related to iris dataset. That is, the dataset does not have any null values and the data type of ID is integer and the data type of other characteristic are float and data type of species is object. Now let's look into the uh, various species that are present in the dataset. So from here we can see that three type of species are there, namely versicolor, setosa and virginica. Now let's visualize the data. So from this distribution plots, we can observe that sepal length, sepal width are almost normally distributed, whereas petal length and petal width is kind of bimodal distribution curve. So basically petal length and petal width have chance of internal grouping. Therefore, for these variable we can do our further analysis. Now let's look into pair plot of iris dataset to look into the relation between different characteristics with respect to the species. So basically blue color is showing setosa, orange color is versicolor and green color is virginica. Now from these plots we can observe that setosa is having very different characteristic in comparison to versicolor and virginica, whereas characteristics of virginica and versicolor are overlapping. Now, let's move ahead with finding correlation between the characteristics. From this heat map, we can observe that petal width and sepal length are highly positively correlated with correlation coefficient of 0.82. Sepal length and petal length is also correlated with correlation coefficient of 0.87, and petal length and petal width are very highly correlated with correlation coefficient of 0.96. Now let's look for outliers and do the outliers treatment. So from this box plot we can observe that sepal width is having outliers, so we will go for soft capping. Basically in soft capping we are capping the lower range outliers with 0.01 quantile value and upper range outliers with 0.99 quantile values. Now we will drop the column which are not required for the further analysis, that is ID and species. Now let's move to the clustering. So basically we will perform clustering using k-mean clustering method. For that, first of all, we need to clear that whether clustering is possible or not. So this can be done by using Hopkins. So we can see that we are getting 0.839 as Hopkins value, which is a good indicator that we can move ahead with the clustering process. Now, the target is that we need to find the optimal number of cluster that we need to go for with k-mean clustering. For this, we will plot elbow curve and silhouette score. Elbow curve, we can see that there is a breakpoint when k equals to 3, and after that curve is becoming flatter. There is no as such change in the slope, but there is a breakpoint when we are taking 3 number of clusters. But still it is not clear that we should go for 3 or not, or we should go for 4 number of clusters. So we will perform silhouette score. Now, from silhouette score, we can observe that with 2 number of clusters, silhouette score is highest, that is 0.68. And with 3 number of clusters, silhouette score is 0.55, which is the second highest. And it is a wrong practical implication if we go for silhouette score with if we go for highest silhouette score. So we will take silhouette score as 0.55, and therefore we will go for 3 number of clusters. Now we will perform k-mean clustering, and here we can visualize the cluster using petal length and petal width column. As I earlier mentioned, that petal width and petal length are having bimodal distribution. Therefore, there are chances of internal grouping. Therefore, we are using these two columns for the visualization of clusters. Here we can see that green clusters are setosa, orange one is versicolor, and red one is virginica, with blue color dot is showing the centroid of respective clusters. Thank you for watching the video. I hope things are much clear regarding the IRIS dataset.